Hello everyone. In this video we present CADFS, a data-centric framework for generative computer-aided design with vision language models. The core aspect of generative computer-aided design is a learnable design history representation. Existing representations can only reference operations explicitly defined in a design history and cannot refer to created geometry, like specific edges or faces, which is required for advanced operations like fillet or loft. As a result, prior CAD generation methods fail to model advanced geometry. In CADFS framework, we present a new design history representation based on FeatureScript, the native programming language of the Onshape platform. Unlike previous representations, FeatureScript allows implicitly created geometry to be referenced through explicitly defined entities, which makes it particularly suitable for language models. To facilitate training models in this representation, we create a dataset of 450,000 real-world designs of varying complexity with natural language annotations. Compared to prior datasets limited to sketch and extrude, our dataset covers 15 operations such as chamfer, loft, revolve, text, and more. Finally, we show that a large vision language model trained on the new dataset for text condition generation and image condition reconstruction tasks can successfully model complex designs beyond sketch and extrude. CADFS represents the design history as FeatureScript code. A key element of FeatureScript is its query mechanism, which allows us to refer to geometry that is not explicitly defined in the code. Let us illustrate the power of queries with a simple rocket model implemented in FeatureScript. First, we revolve a sketch to make the body of the rocket, and extrude a sketch to make a wing. Next, we want to round the sharp edge of the wing using fillet operation. Notice that this edge is not explicitly defined in the code, so we identify it using a query as the edge created by extruding the junction between the arcs of the wing profile. After that, we query the entire wing and replicate it. Finally, we add a stand that attaches to the rocket on the same face as one of the wings and use a query to identify this face. This ability to reference implicit geometry makes FeatureScript a powerful representation for generative CAD. To train FeatureScript generation models, we collect a dataset based on real designs created on the Onshape platform. To convert Onshape's internal design representation into FeatureScript code suitable for training, we develop a pipeline that reparameterizes primitives, simplifies operations, and performs other steps to obtain clean, concise, and consistent modeling scripts. The processing results in 450,000 real-world designs covering 15 modeling operations. To enable text condition generation, we annotate our dataset with natural language descriptions using a two-stage LLM-based pipeline. First, the annotator generates a step-by-step description of the design process from the FeatureScript code and documentation, formatting instructions, and few short examples. Then, the reviewer ensures consistency with the original code by verifying the correctness of the operation sequence, resolving ambiguities, correcting terminology, etc. Together, these components yield accurate, interpretable, and well-structured textual descriptions. We use the new dataset to fine-tune the Qwen2VL2B model for text condition CAD generation and multi-view reconstruction. For multi-view reconstruction, we provide the model with the bounding box of the design to reconstruct it in its natural dimensions. Generation examples on a deep cut test set covering the basic sketch and extrude operations are shown at the top. Generation examples on our new CADFS benchmark covering diverse geometric operations are shown at the bottom. We compare the model based on our framework with models trained for generation of a token sequence and Python code. Our framework shows strong improvement, demonstrating higher complexity and geometric accuracy of the produced designs, thanks to the extended operation set. It improved the geometric accuracy of text condition generation by up to 60% and significantly improved the geometric accuracy of multi-view reconstruction, especially on the new benchmark with advanced modeling operations. In this work, we present three main contributions. First, a FeatureScript-based representation supporting 15 modeling operations going beyond sketch and extrude. Second, a diverse dataset of 450,000 real-world CAD designs of varying complexity, enriched with natural language annotations. And third, a LLM-based framework that brings all the above components together for text and image condition CAD generation and reconstruction. The dataset, code, and model weights are available at the project page. Thank you for watching.